Okay, so our first look at calculating delta G for a reaction based on enthalpy and entropy values. And we're going to go back to an old friend that we've seen in previous videos, 2C4H10 as a gas, plus 13 O2s as a gas, makes 8 CO2s as a gas, plus 10 H2Os as a gas. And we're going to calculate delta G. Now, a lot of times you have more than one way to go about this, or more than one apostle to go about this. If you know what delta H for the reaction is and delta S for the reaction is, you can calculate with the equation we saw in the last video. Delta G is delta H minus T delta S. If you're given only the individual enthalpy of formation and entropy of formation for each substance, you'll have to go through and calculate delta H for the reaction and delta S for the reaction, and then plug it into the delta G as delta H minus T delta S equation. We're going to work this one the short way, because this was our example both in our delta H calculation earlier, in an earlier video, and our delta S calculation in an earlier video. So for this one, delta H for the reaction, we calculated it to be minus 5314. Kilojoules per mole. And delta S for our reaction, we calculated this to be plus 310.4 joules per mole Kelvin. So our job here is to calculate delta G for the reaction in kilojoules per mole. That's how we normally calculate delta G. Delta G is usually in the scale of delta H. Okay, so we typically calculate in kilojoules per mole. That means that we typically need to convert the delta S to kilojoules per mole Kelvin for our calculating. So move the decimal 3 places to the left, 0.3104 kilojoules per mole Kelvin. So this is just a conversion within the decimal system to kilojoules from joules. But we have to do that so our units cancel out correctly. So delta G 0 is delta H 0 minus T delta S 0. Where's our temperature? Well, it's all at standard conditions. That means temperature is 298 K. So we plug in our numbers. Delta H was minus 5314 kilojoules per mole, minus T, which is 298 K, times 0.3104 kilojoules per mole Kelvin. So our Kelvin temperature cancels. We got kilojoules per mole, subtracting kilojoules per mole, we get kilojoules per mole out of that. So delta G, we can calculate that pretty easily. 5314, remember to make it negative. So minus 5314 on my screen, minus 298 times 0.3104. Messed that up. 5314, flip the sign, minus 298 times 0.3104. Minus 5406.5. So that is delta G. We should also be able to tell if this is spontaneous or not. Delta G values are spontaneous when they are negative, when there's energy to be released to the surroundings. A negative delta G, that's spontaneous. So since it's negative, that reaction is spontaneous. It's also spontaneous at all temperatures because entropy is positive and enthalpy is negative. So from that table we had on a previous video, this will be spontaneous at all temperatures. Come back, I'll show you another example.